difference between coal and diamonds, between sand and computers, between good health and bad health, is how the atoms are arranged. Today's manufacturing technologies really can't arrange atoms with any degree of control. It's sort of like nature has given us a bunch of Lego blocks and we got boxing gloves on our hands. Nanotechnology is going to let us take off the boxing gloves and arrange the fundamental building blocks of matter, the very atoms and molecules, in most of the ways permitted by physical law. My name is Ralph Merkel. I'm a principal fellow at Zyvex. I do research in nanotechnology. Nanotechnology is about very, very small molecular machines. We can't build them yet, but we will in the coming decades. A nanometer is a very, very, very small distance. If my arm is a meter in length, then 1,000 times smaller than that is a millimeter, which is something you can see, but it's small. And 1,000 times smaller than a millimeter is a micron. And you could barely see a micron under a very powerful optical microscope. And 1,000 times smaller than a micron is a nanometer, which is a billionth of a meter. And a nanometer is about the size of an atom. So it's down on the scale of the atoms and the molecules that we can build these molecular machines. So we're looking at a theoretical device. This hasn't been built. As you can see, it has individual atoms. Each of those little circles is an individual atom. And as a consequence, this device is pretty small in size. It doesn't have a lot of range of motion, on the order of a few angstroms, but within that range of motion it can move and fiddle and control something and position it with 6 degrees of freedom. It's X, Y, and Z, roll, pitch, and yaw. Now, if you ask, could this be synthesized using existing organic chemistry, the answer is, I don't think so. This structure, and indeed a lot of these very stiff, complex molecular structures, look like they're well beyond existing synthetic capabilities. So we have to develop a new set of capabilities in order to make them. Now, chemists have been arranging atoms for centuries. What we want to do is to bring to the manufacturing process the precision that a chemist brings in the synthesis of a molecule. When people talk about nanotechnology, they think about building very, very tiny things. But in fact, we want to build things at all sizes. We want to build big things. Well, how do you build a big thing out of molecular parts? We're starting with parts that are about a nanometer in size. Suppose I take those nanometer parts and I build 2 nanometer parts, twice as big. Then I take those 2 nanometer parts and I build 4 nanometer parts. Those are twice as big. And then I take those 4 nanometer parts and I build 8 nanometer parts. Those are twice as big. At every level, the parts are very precise. If you look at them, they're molecular in the precision, but they're getting bigger and bigger. That's called convergent assembly. When we're talking about what future technology will look like, it's always a bit uncertain, but one image that seems to make sense is that nanotechnology, molecular manufacturing, will be a kitchen appliance. It will be a box that you put in your kitchen, and when you want to build something, there's a menu, there's perhaps a control panel on the front, and you say, I want item number 47, And item number 47 is a toaster. So you press the control buttons, you pour in the equivalent of toner, molecular feedstock, so these devices can have something to work with, and this box goes to work, and you come back an hour or two later and there's your toaster. Or a chair. Or another box. We're looking at a transformation that's going to have as big an impact as the Industrial Revolution, if not more. We'll be able to build products, all the products that we see in the world around us, with molecular precision, with lower cost, greater strength, less pollution. It's a revolution in manufacturing, and we see it coming in a few decades. We're going to see technology transform our lives in ways that we can scarcely understand right now, but in ways I think that will improve the human condition, that will benefit all of us.